2 towers, a sword shape, built on a sea that didn't even exist. This hole in the ground will hold a 211-meter tower.
Every engineer said impossible. 4 years, 2,067 piles, 8 core walls.
One insane engineering decision. Watch. This whole story starts with an empty sea.
And the biggest urban gamble in history. Qatar literally vacuumed the seabed and stacked it into dry land, 38 square kilometers. The entire tower shape came from this, a pair of swords on a coin. Literally. Here's the crazy part. Consult designed a tower where no 2 floor plates are identical. 8 concrete core walls.
8 concrete core walls carry the entire 211-meter structure. Each zone behaves differently under load. This load path is everything. And
get one connection wrong and the whole system fails under gravity.
Before a single pile goes in, they must know exactly what the ground is. Made of below. The top 20 meters, loose reclaimed sand.
And soft marine clay. It can't hold anything alone.
Feel this. Loose sand up top, soft clay in the middle. This hard rock is the only thing saving the project.
The SPT blow counts near the surface were dangerously low.
This soil had almost 0 bearing capacity. But there was one massive problem.
This reclaimed ground cannot support any skyscraper load at all.
So they designed 2,067 bored piles straight through the bad soil.
Into solid rock, every single one. Each bored pile is a meter wide. Without bentonite slurry, the borehole walls collapse. This liquid is the hero. That rebar cage goes inside each pile. It's 35 meters of steel. Watch closely. That cage fits with centimeters to spare inside the hole.
Concrete goes in from the bottom up, using a tremie pipe. Otherwise, segregation destroys the pile completely. Concrete poured from the bottom up.
Any air pocket in a pile that depth means complete structural failure.
Every single pile gets a sonic integrity test. If the wave breaks, rejected.
They load-tested representative piles to 1.5 times the design load.
The pile barely moved. Good. 2,067 pile tops. Across a 48,000 square meter plot. The total piling length
was 50,000 meters. Here's the crazy part. After drilling, cut off.
The top meter of contaminated concrete from slurry. Those exposed bars.
50,000 meters of bored pile beneath my feet. More foundation steel than most bridges ever use.
Now you might be thinking, how do you hold back the gulf while digging 10 meters down?
The secant piles interlock like teeth.
Hard concrete alternating with soft, cut through each other. Where loads were higher, a 1.5-meter thick diaphragm wall.
Reinforce the perimeter. Depth, 10 meters. This single leak
could destabilize the whole excavation face. One crack multiplies. Any air pocket in a pile that depth means complete structural failure. Into the leak. The foam expands and seals against Gulf groundwater. Wait until you hear this. The dewatering pumps ran non-stop for over 12 months straight during excavation. 10 meters of excavation. In 48,000 square meters. That's a volume bigger than 20 Olympic swimming pools. They measured wall movement every day. Even 20 millimeters of deflection would trigger an emergency stop.
10 meters below the surface of land that was under the sea. 5 years ago. Think about that. Think about that.
The pile cap collects load from the column above
and spreads it across multiple piles below. Essential, blinding concrete first.
It sounds small, but without it, the reinforcement sits in mud. Ground beams tie all the pile caps together. Without them,
the piles could splay apart under load, vibrating fresh concrete.
Is not optional. Miss a void in a pile cap,
and it cracks under the tower above, in 45-degree heat.
Concrete cures too fast. Cracking starts within hours if unprotected.
Bringing these history-defining moments to life takes everything we have. Join us next time.